In this video, I will tell you all about parallel lines, and I will also go through some common questions that are asked about parallel lines. So first, what are parallel lines? Well, parallel lines are lines that exist in the same plane that never, ever intersect. So that means that they will be the same distance apart, and as they extend forever in both directions, those two lines will never cross and never meet. Well, what makes them never cross and never meet? Well, in fact, what is true about parallel lines is that parallel lines have the same slope. And because they have the same slope, that allows them to never ever intersect. Let's take a look at these two parallel lines on this graph. First, notice that they exist in the same plane. Then, let's take a look at the slopes. So I'm going to identify, looks like that's a good point there, and that's a good point there. So looking at the slope of that line, I see that I rise 3 and run 2. So the slope of this line up on top is 3/2. Now for the slope of the bottom line, let's find a point about right there, looks good. And the next point right there. Once again, it looks like that line rises 3, and runs 2. So it looks like the slope is once again 3/2. And because those two lines have the same slope, they will never cross. Think about it. Both lines rise 3, run 2. Rise 3, run 2, meaning they will never cross. Let's take a look at some common questions about parallel lines. First, if a line has a slope of -3/4, what is the slope of the line parallel to this line? Well, because parallel lines have the same exact slope, the slope of the line parallel, that symbol means parallel, the slope of the line parallel will also be -3/4. Again, the same slope. Next question you may be asked is, are these two lines parallel? Well, in order to determine whether two lines are parallel, I need to look at their slopes. It looks like both of these lines are in slope-intercept form, which is y equals mx plus b. In slope-intercept form, the slope is m, or will be the coefficient of x. So you can see in the first line, the slope is 2. In the second line, the slope is -2. You may think, oh, they're very close, they have to be parallel, but in fact they are not parallel, so I'm going to say no. And the reason is that the first line has a slope of 2, the second line has a slope of -2, the slopes are not equal, so these two lines are not parallel. Next question that is commonly asked is, write the equation of the line that passes through the point -6,4 and is parallel to the line y equals 5x minus 2. Now, in order to write the equation of the line parallel, I remember parallel lines have the same slope. Since this equation over here is written in slope-intercept form, y equals mx plus b, I can identify the slope as being 5. I am also given a point that is on the line, and that point is the point -6,4. So now I need to write the equation. I'd like to talk about a common mistake students make. They immediately go to slope-intercept form, y equals mx plus b, using this slope of 5 and the -6 or the 4, specifically usually the 4. But this is incorrect because in slope-intercept form, this b value is actually the y-intercept. Over here in this point, the 4 is not the y-intercept. I only know the 4 is the y-intercept if the x-coordinate of that point were 0. Because I am not given the y-intercept, I need to actually start in what's called point slope form. And point slope form looks like this. Y minus y1 equals m times x minus x1, where x1, y1 is the point you're given, and m is, of course, the slope. So let's go ahead and fill in what we know. We know x1 and y1, and also the slope of 5. This line would be y minus 4, because y1 is the value of 4, equals m is 5, because the slope is equal to the slope in this problem, 5, x minus, and it looks like here I would be subtracting a negative 6. X minus a negative 6 changes to x plus 6. And there we have it. If you can leave your equation in point-slope form, that would be your final answer. However, if you wanted to put this back into slope-intercept form, like the form we were given in the original problem, you would need to first distribute the 5 by multiplying it in, and then adding over 4. So depending on what form you need it in, slope-intercept form would look like this, and point-slope form would look like this. Let's look at another example that would often show up about parallel lines. Write the equation of the line that passes through the point 1, negative 5 and is parallel to this line. It looks like this time our line is given in that point-slope form that I just showed you. The y minus y1 equals m times x minus x1. Now, because I want it to be parallel to this line, the only thing I care to know about this line that I'm given is the slope, because I want my two lines to be parallel. The slope looks like is right here, because it's the value of m. So the slope that I'm going to use is the same exact slope, because parallel lines have the same slope, so I'm going to use a slope of 1/2. Once again, because the point that I'm given is not the y-intercept, it doesn't have an x-coordinate of 0, I need to first put this line in point-slope form. Once again, point-slope form is y minus y1 equals m times x minus x1. Plugging in the values for x1 and y1, and also my slope of 1/2, I would get y minus, since I'm subtracting a negative 5, just like our last example, that'll change to plus 5, equals my slope of 1/2 times x minus 1. This time I'm going to go ahead and leave it in point-slope form. However, if you did need to put it in slope-intercept form, you saw that on the last example. I hope you found this video useful. If you did, make sure to like it and subscribe so that you're notified as new weekly videos are posted.